Hello, everybody, and welcome back to this session after lunch. Now, my name is Michael Crawford, and I just want to thank Adam, Harry, and all their helpers for setting up such a wonderful conference. One of the most important things is the communication of science to industry and backwards. And this is one of the wonderful things that they've achieved at this conference. Now, it's my great pleasure to be able to introduce to you three of the most wonderful people on the planet, and my friends and colleagues, and who are going to follow on from Bill, because Bill actually said something very important. He said that the brain is now the most important thing to worry about. And that's 100% true. Mental ill health has now overtaken all other burdens of ill health in Western countries and is being globalized. And importantly, the seeds of mental ill health are sown in the womb and in the child. So it now gives me, first off, greatest pleasure to invite Captain Joseph Hibbeln, acting section head of Nutritional Neurosciences at the National Institutes of Health in America. Dr. Hibbeln.
Thank you, Adam, and thank you, friends and colleagues. It is a privilege and an honor to be able to speak to you today. I will perhaps be presenting a more dry and focused talk than you are used to me seeing, which is entitled Quantitative Modeling of Nutritional Benefits and Methylmercury Risks in Commercially Caught Fish. Now, there is one mistake on this slide, and that is that Philip Spiller's name should be about 10 times as large, and that should be about 10 times as small, and he should be here. Because Philip Spiller, who is a lawyer, has been pressing this issue within the FDA for more than a decade and is creating potentially great transformations. What is not a mistake on this slide is that this presentation does not represent any policy or position of the United States federal government, and it is solely my responsibility, the scientific opinion of this presenter. Here is the issue, and I will read it to you. From the United States Senate, August 6, 2013. Mr. President, we are writing respectfully to urge your administration to end years of delays and update the FDA seafood advisory to pregnant women swiftly. This is the third time a bipartisan group of senators has written to you requesting your help in removing the roadblocks in finalizing the FDA advice on pregnant women and seafood consumption. Pregnant women and healthcare professionals, however, are still waiting, despite numerous commitments from the President and the FDA in 2011, in 2012, and in 2013. Third time. We understand that the FDA advice to consumers and the accompanying net effects report, which is the scientific background, have been drafted for months, in fact since 2009, but are stuck in interagency reviews. Each day, the new FDA advice is delayed, means pregnant women are without sound science, driving recommendations to make decisions to make informed decisions about seafood consumption in pregnancy. This is signed by 21 senators, 1/5 of the Senate. It was in 2013. We're still not done. A similar letter in 2010 was written by Dr. Crawford. They even ignored that. So what is this issue? How does the FDA play a role? What's going on here? The FDA's mission relating to fish. FDA has federal regulatory responsibility for the safety of fish marketed in the U.S. That is to say that the FDA has the legal authority to remove fish from interstate commerce if they present a reasonable possibility of injury to health. So, what is the challenge? The challenge is to answer this question. Does a reasonable possible of injury exist from commercial fish due to methylmercury in them? If so, to whom would it injure? Well, it would injure the developing fetus. So here's the FDA's dilemma involving methylmercury. The dilemma is this. We know methylmercury in high concentrations is unequivocally neurotoxic and poisonous. We know from the Minamata experience in Iraq when there was poisoned grain that we see neurodevelopmental harm and problems. The problem is it's about 1,000 or a 10,000-fold exposure of methylmercury than what you get in commercially caught fish. So, but unlike Japan and Iraq events, there are no reported overt clinical effects from methylmercury exposure. No cerebral palsy, mental retardation, etc. So if there's no overt clinical effects, well, are there subtle and subclinical effects from this level of expression of mercury? If there are effects, under what circumstances do they occur and how significant are they? Yeah. Here is the raw data. This is the data from women's exposure of blood level of methylmercury in the Faroe Islands, primarily from pilot whale, not commercially caught fish, on the x-axis, and the test scores of the Boston naming test on the y-axis. It is this graph, and it are these data that drive the toxicological level of methylmercury. Now, it may just look to you that this is a randomly associated set of spots where you can't possibly derive a correlation or causal axis. But very clever mathematicians have derived levels from this data. First, at the level of 58 micrograms per milliliter here, that's the bottom 95th percent level that you could barely detect any differences in the Boston naming test. Right there. You can detect maybe that there's some diminishment in the Boston naming test. Now from here, 58, from a toxicological perspective of the world, you want safety. So there's a 10-fold uncertainty factor added from here, from here to there, the reference dose. Now note the name. This is not a toxicological threshold. This is a reference dose. This is often assumed to be a toxicological threshold for which, if you exceed it, you get Minamata disease. It's not. It's a threshold where you get, you're in between the 10-fold uncertainty factor where you get a subtle detection of changes in the Boston naming test. Now, from this data, we see a different symbolic presentation. There are 60,000 kids in the U.S. who are above the reference dose, which obviously means that they're being poisoned deliberately by the power plants with deadly mercury emissions. My personal view is that at these low trace levels of methylmercury, it is much more potently symbolic as a symbol than it is potent as a neurotoxin. So, the FDA went back to to the National Research Council and said, wait a second, subclinical effects, traditional safety assessments don't really answer this question. You say that 60,000 kids are born at risk of developmental deficits. What specifically do you mean? And the National Research Council responded to say, well, the committee does not believe it's really possible to estimate a meaningful number of children that might be affected within the at-risk population. And at risk for what? For a small diminishment in verbal learning in the Boston naming test. Okay, so that was 2000. In 2001, the FDA, out of prudence, not out of mathematics, out of prudence, said women should not eat more than 12 ounces of fish per day during pregnancy. Well, what does this have to do with the reference dose? You can't find any mathematics that comport 12 ounces of commercial fish today and the reference dose. It doesn't exist. It was posited because at that time from the American Heart Association and Bill Harris's work, about 12 ounces a day was very good for cardiovascular effects. So, well, 12 ounces a day, that's probably all that the women need. What was not done was any calculation of the risk of problems over 12 ounces, at 12 ounces, or below 12 ounces. And the 12-ounce ceiling was retained in the 2004 update. And all of this is based on the concept of reducing risks with tenfold uncertainty factors from methylmercury. So in 2004, 2005, the FDA started to quantify the risk of methylmercury and estimate the likelihood of neurodevelopmental effects and the size of those effects through a range of U.S. commercial exposures resulting from mothers' consumption of commercial fish during pregnancy. But then in 2004, these doggone scientists started to note that eating fish during pregnancy was associated with better cognitive outcomes in the offspring, and that most reported outcomes appeared to be improvements. And some troublemakers noted that eating more than 12 ounces a week could be better for the kids than eating less. But methylmercury still appeared to have to adversely affect outcomes in most studies that measured methylmercury exposure in addition to fish consumption. So methylmercury could reduce the size of the benefit of fish or could cause the beneficial effects of fish to be aversive if the potency of methylmercury is too much. So you need to put those things in the calculation. So the major takeaway for us and FDA was that we needed a new approach to assessing risk, and that this approach should mathematically account for both the adverse contributions of methylmercury and the beneficial, presumably nutritional contributions from fish. And that this approach should finally wind up with a net effects assessment on verbal development and IQ from eating fish. And that this net effects should vary with species of fish, because they have varying amounts of methylmercury, they have various amounts of beneficial nutrients. So our net effects approach was to calculate a dose-response functions first for the adverse effects on cognitive development, IQ, from methylmercury, independent of any benefit, and then to calculate the dose-response functions for any beneficial effects on cognitive development, presumably from one or more nutrients that were independent of methylmercury. And then to calculate the dose-response effects for the net effects, that is, overdosage, the adverse effect, and the beneficial effects added together. So here's the graphic, presumably, it might look like, my impression of what it may look like. We have no official release of any governmental information, but this is about how it is. Now this one should be read, and that's methylmercury harm from eating a market distribution of fish through 0 up to 1,400 grams per week, And I made this line exaggerated because it's much slower, much less. But for illustration purposes, you can see the more methylmercury you're being exposed to as an isolated function, you have a change in IQ that's negative. Now, for the nutritional benefits of fish, it's not a straight line. It appears really that from 0 up to about 12 ounces a day, you have a rapid increase. And from 12 ounces a day, there may be a slight benefit, hard to say. But clearly, this is the biggest effect. Now here, the magnitude over the distribution of women in the U.S., this is likely to be about the harm from methylmercury from the EPA estimates for the women eating the most fish in the U.S. compared to the least fish. They can expect a neurotoxicological effect from methylmercury on their children. They can expect an effect from that methylmercury of a loss of IQ of 0.01 points. They can expect a loss of IQ from not eating fish of 6 points, 5 or 6 points. When you combine the harmful effects over dosages with the beneficial effects, you see that there's a rapid rise here, the sum total from 0 up to 12, and then after 12 you have a peak, and over a long dosage effect, you have a net negative effect. Now please note that this is a maximal benefit effect at 12 ounces per week. This is not an upper limit from which afterwards, if you exceed it, you will cause harm. It's just that you start to get some diminishment from methylmercury. That is not a toxic upper limit, in my opinion. That is a maximal benefit limit. So, the net effect summary, to my perspective, is that benefits of typical commercial fish consumption rise rapidly from 0 to 12 ounces, up to about 5.5 IQ points, then begin to plateau. The risks of loss of IQ due to methylmercury, about 0.01 IQ points. So the net effects of eating commercial fish are positive, 5.5 minus 0.01, about, 5.49 IQ points. Best modeling we can do. 12 ounces a week should not be considered an upper limit, but a maximal level of benefit. This summary does not reflect any policy or position of the National Institutes of Health or the U.S. federal government. A similar net effects assessment has already been completed and published by the FAO and WHO, which of course we as the federal government don't recognize. Nonetheless, they modeled specifically 70 different species of fish, and all species have a net beneficial effect through at least 24 ounces a week, with an upper bound estimate of the toxicity of methylmercury. All species below 0.5 methylmercury, ppm methylmercury, have net beneficial effects through at least 24 ounces a week. Some high methylmercury fish have a net effect immediately with the upper bound of mercury is used. Those fish include marlin, orange roughy, which we know is such a unique fish, it doesn't have omega-3s, right? Very strange. Marlin, orange roughy, big-eye tuna, king mackerel, shark, and swordfish. So, ahead of the FDA and ahead of HHS, or ahead of WHO, has been the Dietary Guidelines for Americans, which is a slightly different agency and process. This is Health and Human Services and USDA. Now, this advisory now includes a minimum consumption target for fish. A minimum consumption target for fish. The official dietary advice of the U.S. federal government is that women should eat not less than 8 ounces per week. But it does say 8 to 12. Why does it say 8 to 12? Well, now you know the history. It wasn't calculated as a toxic upper limit. It's just ensconced in symbolism, in my opinion. And the dietary guidelines say women should choose sources that are lower in methylmercury, and that other aspects of the advice are the same as the 2004 advisory. Avoid the four high methylmercury species. Now, most remarkably, and perhaps a shift from an attitude we saw in the slide, the advertisement from 2004, I saw this from the Environmental Working Group, which has now saying people who follow the Obama administration's guidelines on seafood eating consume dangerous amounts of mercury, a potent neurotoxin, or too few essential omega-3 fatty acids. That is a radical transformation from just a toxicological view of fish to eating too few fatty acids. So perhaps the Environmental Working Group is in agreement with the Senate that we need to change things. And federal government advice on seafood consumption fails to give people what they desperately need: precise, detailed information about foods that provide sufficient omega-3 fatty acids with minimal mercury contamination. So what might this potential advice look like if we can ever get it out of the various agencies and committees who all must have their opinion on it? What might it look like? It might look like the graph I showed you. It might look very much like the 2010 dietary guidelines, because we like to be consistent in the US government. Well, the focus of the US advice in 2001 and 2009 was minimizing risk. The advice now should be focused on maximizing benefit, that fish could provide the developing nervous system, maximize the benefit of nutrients, and minimize the risk from methylmercury. That's what the potential advice could potentially look like. So in conclusion, fish during pregnancy could benefit cognitive development or hurt cognitive development, depending upon the amounts of fish and the types of fish. Public health entities can maximize management strategies to both maximize potential benefits and minimize potential risks, so long as they have the math, and so long as the net effects assessment gets published and gets out of committees. Public health entities can do this through a net effects approach, which I've shown you, that includes both quantitative estimates of the adverse effects and of the beneficial effects. Thank you very much for your attention.